In this video, we will look at the definition and purpose of earthworks. Earthworks involves loosening, removing, depositing, and compacting topsoil, soil, or rock. These materials are what is often covering the ground over which the road is to be built. However, roading projects may also need to be built upon developed land and existing roads that may already be at the required levels and so do not require significant earthworks. We usually only require significant earthworks when we are building a road along a new route across undeveloped land, otherwise known as greenfield sites. This photo shows the start of the earthworks of the Beach Road intersection, which we looked at in the road design topic, and which we will also look at in this topic. A copy of the drawing set is on this topic page. The site was originally farmland, like the land in the background. The topsoil has been removed. They are now building a fill embankment. The orange pegs set out the extent of the road, that is the width of the road earthworks formation, and also the road itself. The long poles are to allow the road edge location to be extended up through the fill as it is built. The primary purpose of road earthworks is to provide a long-term stable platform of sufficient strength onto which pavement layers can be compacted. There are several things in this definition that should be noted. Firstly, the earthworks create a long-term stable platform for the road. That is, the formation created by the earthworks needs to support the road without moving or settling for long periods of time in all weathers. In the case of a road, that is 50 to 100 years as a minimum, and typically hundreds of years. Many existing roads are built on soil and rock formations that have been in use for centuries, with the road surface itself being changed, but the underlying earthworks remaining largely unchanged. Secondly, the formation created by the earthworks needs to be of sufficient strength to support the road loadings. This means that the materials used and the methods employed to do the earthworks produce a earthworks formation that can support the road. In other words, the formation has to bear the pressures produced by the road without deforming or failing. The pressures that a soil or rock formation can carry is called the bearing capacity. The bearing capacity of a road formation influences the cost of the road pavement above it. Formations with lower bearing capacities require a thicker pavement to distribute the road loadings to levels below the bearing capacity of the underlying soil. Thicker pavements require more sub-base material and more work to construct, and so they cost more. Lastly, the pavement layers are constructed on the formation, so the formation needs to be shaped and compacted so it provides a stable platform for the road formation, or the road pavement. Roading projects often require more extensive and complex earthworks activities than other civil engineering activities. This is because they extend over large areas of land spread out over a long distance, which may have significant changes in topography and underlying soil and rock conditions. In the case of a road, the earthworks are undertaken to enable the road to provide an efficient and effective connection between places. Earthworks may be required for subdivisions, buildings, and other civil engineering developments. In roading, earthworks are undertaken to change the shape of the land to allow the road to be constructed at the alignments, gradients, and crossfalls selected by the designers to provide a safe, comfortable, and efficient travel from one place to another, and to do this at a reasonable cost. Therefore, there are several reasons for undertaking earthworks for a road. Earthworks enable us to provide a more direct route between places by cutting through hills and building above gullies and floodplain areas. They also enable us to build the road to the horizontal and vertical alignments required to provide a smooth, comfortable ride for road vehicles and road users, obviously. Some areas may have soils that are not strong enough to support the road loadings, and so earthworks may be required to improve or replace the soils, or to avoid the problem areas. The road may run over or next to land which may be unstable or potentially unstable, so earthworks may be required to stabilize the land. Sometimes this may involve removing the unstable areas and rebuilding the slope. Another reason for earthworks may be to raise the road above low areas that may be prone to flooding, or to cross swamps, estuaries and other shallow water bodies to provide a more direct route. We will now look at each of these reasons in more detail. The horizontal alignment is the shape of the road as viewed from above. Earthworks allow us to construct a more direct route between places, as well as minimizing the number and the sharpness of bends. This image illustrates this. The red dashed line on this image shows the route of the Northern Gateway Motorway. That is a 7.5 kilometre long motorway that was constructed north of Auckland between 2004 and 2009. The original road is shown in blue. You can see that the new motorway provides a more direct route, with the new road being over 4 kilometres shorter. The new motorway also has less bends and changes in elevation, which means that vehicles can travel the stretch at a constant 100 kilometres an hour. The original road, shown in blue, has some very steep slopes and tight corners, which means that the speeds would vary between 30 and 80 kilometres an hour. As a result of this better route, the new motorway cuts 10 to 25 minutes off the time taken to travel from Auckland to towns north of it. However, constructing this motorway involved moving 4 million cubic metres of earth, as well as building 5 new culverts, 7 bridges and a twin tunnel at a cost of over $100 million. The vertical alignment is the shape of the road when viewed from the side and includes the slope of the road. The road needs to have shallow slopes to allow vehicles to climb the uphill sections and not lose control on downhill sections. Once again, you may need to cut through hills and fill in gullies to achieve this. Here you can see a long section of road. The green line shows the existing ground profile. If we were building the road on the existing ground profile, then the road would be undulating, and some sections, especially the one between chainage 600 and chainage 860, as shown here, would be too steep for some vehicles, such as heavily laden trucks and small cars. So we need to provide a smooth vertical alignment using earthworks to produce the smooth profile shown here. This profile has cut areas from chainage 10 to chainage 380 and from chainage 800 to chainage 1000, as shown here in the red shaded areas, and a fill area in between. The earthworks would consist of cutting the soil from the cut areas and transporting and laying and compacting the removed material to fill the gully between chainage 380 and 800. There may be soft or unsuitable soil that needs to be removed or replaced or strengthened to enable them to support roads. This photo shows soil that is too soft, is so soft that it cannot support the excavator. Most soils are strengthened by compaction to allow a more compact and stronger formation. Softer soils or roads with higher loadings may require stabilization using lime or cement. We will look at these processes in a later video. A road may also be required to run through potentially unstable land. This may be slopes above the road that could collapse onto the road, as shown in the photo to the left, or slopes below the road that undermine the road if they slip, as shown in the photo to the right. In both of these cases, the slopes need to be stabilized. This may involve excavating the slope down to a shallower, more stable angle, or it may involve rebuilding the slope, or it may require a retaining wall. Rebuilding the slope involves excavating the soil back to a stable soil formations and then rebuilding the slope in layers. The excavation involves constructing benches and shear keys in a stable soil that allow the new fill area to key into the existing stable soil and make a stable slope. We'll look at this a little bit more in later videos. Sometimes roads need to cross areas that are prone to flooding, such as low areas around rivers or coastal areas. Raising the road above these areas lessens the frequency and severity of flooding. so lessening the risk of it being flooded and impassable during flood events or high tides. The road may even be raised above existing wet areas such as swamps and estuaries to allow a more direct route to be taken. This photo shows State Highway 16 as it crosses the Waitemata Harbour in Auckland. The road runs on an embankment which is constructed in a tidal estuary area. The designers had to consider the sea levels for all tidal conditions, as well as allowing for sea level rise due to climate change. In addition, they also had to consider that the estuarine muds upon which the road was built were very soft and would settle over time, so they had to add an allowance for that level reduction as well. When the water body gets too deep, then earthworks may no longer be feasible and we need to build bridges or causeways to carry the road. These structures are not part of this course. Having said that, sometimes we need to shape the land so the roads do flood. Stormwater is the surface water resulting from rainfall. A stormwater system is a series of manholes and pipes that collects the stormwater and conveys it to disposal into natural water systems. This is called the primary stormwater system and it can handle most rainfall events. However, there are storms that drop more rainfall than the primary stormwater system can handle. The stormwater cannot drain to the primary stormwater system, or the stormwater pipes cannot transport the water fast enough and surface flooding occurs. The flow paths that the floodwater takes to the natural water system is called the secondary flow path. Where possible, we want that flow path to run down the road, as it causes least damage to the community. If a road is flooded, then it may be impassable for a while, but after the flood has subsided, there will be minimal damage and the road can be used when the floodwater subsides. However, if floodwater gets into houses, then it can cause massive damage, which can take weeks to clean up and cost significant amounts of money in drying the house and replacing carpets and furniture damaged by the floodwater. In addition, the stress and disturbance suffered by the homeowners is yet another good reason to avoid flooding houses. So, in residential areas, we often flood the land so the roads get flooded, not the houses. We will look at drainage in more detail in the road drainage module.